You too.
I'm going to mute myself.
Do that. Headphones. Good call. Good call. Okay. I think everyone just rushed in. Good to see you. Let me start with an apology and a correction because I wrongly said last week that we only have 2 Neurocinos left, which is not the case. It's only 2 Neurocinos that I'm going to host, and then Anna's going to take over. So there will be more. Apologies for the confusion introduced by me. Now, today we're gonna have Müge present a paper on stuttering, I believe, and she already shared the link in the chat. So whenever you're ready, take it away.
Okay, so I'm going to share my screen. Okay. Okay.
Müge, before you start, can you zoom in a bit because it's quite narrow on the screen? Perfect. Thank you.
This is good?
Yes.
Is it good? Yeah. Okay, so hi everybody. Today, for today's Neuroccino, I picked this paper, Knowns and Unknowns about the neurobiology of stuttering. And this is a PLOS Biology Unsolved Mystery paper. So these Unsolved Mystery papers are they point out research topics that need attention. So if there are like a lot of unanswered questions, these papers, aim to stimulate attention to these topics, and stuttering is one of those. And I like this the introduction because it starts with a very vivid description of what person who stutters experience in their daily lives. So I just want to read this first paragraph of the introduction. So it says, "You are at your favorite bakery, craving a pan au chocolat. As you attempt to order, your jaw, lips, and tongue will not move, and no air flows through your voice box. You struggle to get the speech sound out, but however much you try, you're frozen in place and there is no sound. You cannot answer the clerk's friendly greeting, and to your dismay, you can now see that she looks uncomfortable, unsure of how to react. Looking to escape the awkward situation, you end up ordering something you do not want at all, only because it has a name that you can say without trouble." So this is one of the, avoiding strategies that people who stutter, usually if they cannot say that word, they just try to say just something else. So anyways, I thought this is a very nice description of the disorder. So stuttering speakers exactly know what they want to say, and they can coordinate and move their articulators, their vocal organs, but sometimes they intermittently lose control. And then these articulatory movements freeze or fall into an idle loop during instances of stuttering. And this is characterized by speech blocks, sound and syllable repetitions, and sound prolongations. And it doesn't only have an effect on the speech and articulation, but it also affects other body parts, it causes eye blinking or grimacing in the face, or extraneous limb and body movements. And also it has some covert symptoms shame, frustration, and social anxiety are common. And so stuttering onsets occurs either abruptly or gradually during early childhood. So in kids between the age 2 and 5. And so according to the statistics, 8% of preschool age children can, begin stuttering. So which is not a small number, I think. So, so it's difficult to, study stuttering because during this very young age, it's a critical period for speech and language development because they learn new vocabulary, like how to put sentences together, but they are also, developing cognitive, social, and emotional skills. And all these, environmental interactions affect the child's development. So they say that it's hard to disentangle the contribution of genetic factors and these like environmental emotional factors. And the other problem in like stuttering research is this: there's so much intra and inter-individual variabilities. Sometimes the severity of symptoms in people who stutter varies in like weeks and months. They have these periods with a lot of stuttering and periods with no stuttering. And it varies with personality, social contexts, like communication goals, and some of the strategies people use to hide their stuttering changes. So all these factors make it difficult to study stuttering. And but overall, summarize stuttering in like one sentences, it's the breakdown in speech motor control at its core, with severity of symptoms influenced, but not caused by higher order language, cognitive, and emotional processes, they say. So, and then they focus on, what did I do? Okay, they focus on, interesting, different questions about stuttering. So first of all, is stuttering genetic? So stuttering is definitely a rich phenotype, and there are multiple risk factors, and there are like small individual genetic differences in every individual. And okay, and they think that can be there are genetic factors at play, because so probability for both twins to stutter in like twin studies, the probability for both twins to stutter is higher in monozygotic than dizygotic twins. And also the family history is important. So people, for example, 50% of individuals who stutter also have another person in their family who stutters. So they at least report one additional relative who stutters. And also there's a sex bias. So stuttering is more common in males compared to females, and this ratio is 1:4. So quite a big difference, actually. So previous studies, found that stuttering has been linked to variants of lysosomal targeting pathway genes. And then especially like in family studies, they could, isolate some genes that are really involved in stuttering. But then when they try to replicate these with, genome-wide association studies, they cannot try to, they were not able to replicate this, previously identified genetic factor in like these, so they cannot identify this in general population with stuttering. So the authors think that one thing that needs to be done is to overcome this significant lack of statistical power and extend the clinical routines by collecting DNA samples from people who stutter. So and then they talk about the neural markers of stuttering. Implicated cortical areas in stuttering are the areas that are involved in speech motor planning and control networks. So these include like frontal lobe regions such as the motor cortex, premotor cortex, inferior frontal gyrus, and like frontal operculum, insular cortex, presupplementary and supplementary motor areas. Also like supramarginal gyrus, auditory regions, also subcortical structures as basal ganglia, thalamus, cerebellum, and limbic brain regions like reward processing and emotion regulation regions, nucleus accumbens, amygdala. So it's all over, basically. And so they they find like neural activation differences in these regions, and that there are different studies. Also, they find like alterations in white matter structures, like the arcuate fasciculus, superior longitudinal fasciculus, frontal aslan tract, corticobulbar tracts, and cerebellar peduncles. And they found like morphological differences in these cortical and subcortical structures, like decreases in cortical thickness, decreases in gray matter volume. So yeah, it's all over the place. And but importantly, they find like differences between adults and children. So in contrast to children, adults exhibit larger like speech-related activity and connectivity within the right hemisphere, so non-dominant, like language dominant hemisphere. And then they think this is probably a compensatory mechanism. So if there's an abnormality in the left hemisphere structures, the right hemisphere structures take over to compensate. But in contrast to adults, in children who have like persistent stuttering, because a lot of children they stutter between the age of 2 and 5, but then as they get older, they recover from stuttering, like just without doing anything. But some children go on to have persistent stuttering, and then they find that these children with persistent stuttering exhibit reduced volume of the putamen early in the developments. But this discrepancy diminishes with age and into adulthood. Paradoxically, these adults who stutter exhibit increased neural activity in these basal ganglia structures, including the putamen. So it's puzzling. Lots of unknowns here. So the question, one question is, what facilitates spontaneous recovery in children who stutter? So, for example, this spontaneous recovery is reported in like more than 80% of the children, and this recovery is like complete alleviation of symptoms. So they don't have any more like effort or internal struggle to produce fluent speech. So it's a complete recovery. And then they who likely recovers, like they found that, like, for example, females recover mostly. People who have no family history of stuttering, or if they have a stuttering onset at a younger age, they are more likely to recover from stuttering. So spontaneous recovery is linked to age-related growth in white matter structures that enable fast and accurate sequential speech movements. So these white matter structures like are corticospinal tract, superior longitudinal fasciculus, arcuate fasciculus, and somatomotor part of the corpus callosum, and cerebellar peduncles were reported to, show age-related growth in the in people who spontaneously recover. So, and they have a figure here showing these, the brain regions involved in spontaneous recovery in children and therapy-driven recovery in adults. And then they show that spontaneous recovery shows more like a subcortical cortical neuroplasticity gradients. But therapy-driven improvements in adults are more related to functional reorganization of these, cortical structures of the speech network. And but yeah, so they point out that longitudinal studies are necessary in children. Because a lot of times they collect data in children who stutter, but then when they recover from stuttering, they don't follow up with these children. So they don't have these longitudinal studies in children to understand like what parts, what parts of the brain are improved, and this results in, recovery from stuttering. And then, so yeah, they can stuttering therapy in adults elicit neural reorganization. So they have these, therapies for stuttering. So fluency training therapies. For example, they do like metronome-paced speech coupled with transcranial electrical stimulation, for example, or they do some kind of like risperidone, a dopamine receptor, serotonin receptor antagonist therapy, which stimulates like brain connections, improvement in brain connections. And they do fluency shaping therapy, like involving slow speech, like gentle vocalizations and lighter movements. And a lot of studies find that these kind of therapies normalizes brain activity. So they bring hyper activation or hypoactivation in different brain regions similar to non-stutterers, or they change some connectivity patterns in the brain, like functional connectivity patterns in the brain. But then these are not persistent. Once you stop therapy, in people who stuttering, the hypoactivation or hyperactivation patterns reemerge. And finally, so what are the major unsolved mysteries in stuttering? So first of all, the singing advantage. So they find that singing dramatically eliminates instances of stuttering, but we don't know why this is the case. So one thing is, if we think about the differences between speaking and singing, so both have a melody, but the melody in singing it's fixed compared to speech. So the rhythm and volume dynamics have a fixed temporal frame in singing. For example, the alignment of pitch, duration, intensity when you sing, it's precisely determined to correspond to a certain melody and rhythm. But in speaking, such temporal constraints are less definite, or can be planned and executed more freely. So it's not like you don't have to stick to a certain template. You just, modify it as you like in speech. And then lately there are some studies on differences between in the laryngeal cortex. They identified like a dorsal part of the laryngeal cortex and ventral part of the laryngeal cortex. And then they say that these different parts are involved in different like laryngeal functions. For example, the dorsal part is more involved in like pitch regulation, auditory feedback control, but the ventral part is more involved in vocalizing different like voiced and unvoiced consonants. Like the most common example is if you touch your throat and say like a voiced consonant like B, D, you will feel the vibrations in your throat. But if you say an unvoiced consonant like S or F, you won't feel anything. So the ventral laryngeal cortex is involved in, these, voicing, these kind of, I don't know, like articulatory voicing function. So they think that there might be differences between like singing and voicing and speaking, and then these different brain regions involved in these different functions might be involved differently in stuttering. So something that needs to be like explored. And also the social context in stuttering. So social context is really important to trigger stuttering episodes. So for example, stutterers are, for example, fluent when speech production occurs in a non-social context. But for example, if you're talking to someone, they stutter. But if they're talking to themselves, if they're only by themselves, they don't stutter, for example. So the communicative context and time pressure also, if they're like presenting, giving a speech under time pressure to an audience, stuttering is more likely. So that's why they think that a limbic vocal system is involved. The limbic vocal system, like the periaqueductal gray, the lateral reticular formation, and nucleus ambiguus. So these are regions that support like emotional laughing, moaning, crying. So this they think that this network is more involved. And lastly, as we mentioned before, sex differences. So this is one thing that we need to explore more. So why girls are, it's stuttering is more common in boys, but not in girls. Why girls recover as they age, but boys are less likely to recover from stuttering. So they think that this pre-pubertal girls already have higher estradiol levels than boys in their like blood serum, and this estradiol is a primary form of estrogen. And estrogen exhibits neurotropic and neuroprotective properties that act on striatum, cerebral cortex, and hippocampus. So they think that estrogen might play an important role in in developing these neural pathways involved in like speech motor control. And there is just mention one study. So they do a study in 4-week-old and 8-week-old infants. At 8 weeks, they look at their cry melody properties. And then they analyze the frequency modulation skills and complexity of these cry melodies. And then they find that the ones who have like a serum concentration of estradiol are better at producing more, I think, complex cry melodies. So yeah, that's it's just one study that they cite here, but so yeah, estrogen might be an important factor. And yeah, with that, I think I don't have much time left. So yeah, so these are the basic questions that they point out that people need to focus on to understand, to explore stuttering more.
Amazing, thank you. That was a lot, and I actually learned a lot of things about stuttering I didn't know. But also the opening of the paper is for the wrong crowd, because half the group is set in Bordeaux and it's a chocolatine.
Yeah. Group is
Eduardo
from Germany, but they gave that
Fair enough. I only learned that moving to Bordeaux, that our chocolat is limited to everywhere but Bordeaux. Eduardo, your turn.
Yeah, thanks, Muge, for presenting a really nice paper. So I had a couple of questions. One is, so you mentioned this that singing improved the performance of stutterers. I was wondering whether they mention or whether if there's some link also. As far as I know, also some aphasic patients can improve their performance while singing. So, is there any link related to this aspect of language production? Do you think, or?
I think, I think during singing, you you use your auditory memory more. So it's more like, I don't know, like you use your like memory system, and then maybe in stuttering or in aphasia, it's not so much affected. So that's why you're better at singing. And also, I think, because based on my own studies, like I think auditory feedback control is very important. So in singing, you have a template, a tone, like a melody that you're trying to match. And then you always, hear yourself when you sing, and you try to match your singing with that, auditory template that you have in mind. So it's you use your auditory feedback control more during singing compared to speaking. So these might be like auditory memory and like auditory feedback control might be different systems that we use during singing, but we don't use it as much during speaking. So that's why in maybe aphasia, those systems are not affected, or in like stuttering, those are not affected as much. So that's my guess.
Interesting. Yeah, thank you. The second question is more a clarification question. And is there like a set of sounds that people who stutter tend to produce worse? Like, I don't know, plosives or voiced versus not voiced sounds? like consistently, maybe across languages, or is it more like a general a problem that
Um,
affects any kind of sound?
I'm not quite sure actually. They don't mention like specifically like they're more likely to produce these sounds and these nots. I'm not quite sure. No, I don't know uh, if there are such sounds.
Okay, thanks.
Yeah. Mhm. I think Anna has a question.
Anna has a question, yes.
Mhm.
Hello, thank you so much for the nice presentation.
Thanks.
So I was wondering about two things, especially the differences between kids and adults. So first of all, you showed very early in the presentation the two different neuroplasticity mechanisms that are involved
Yeah.
into the spontaneous recovery versus the therapeutical recovery. And that was in adults, right? Do you know, or do they mention in the paper, are there any differences between this, like these two neuroplasticity mechanisms in adults and kids as well, or is it the same?
So they can't compare the children and adults, unfortunately. So that's one thing they mention in the paper that I think skipped. So this in children, they have a lot of structural studies. So they look at structural connectivity, white matter, and the gray matter volume, things like that. And they don't do a lot of like functional, they don't look at that functional activation. They don't do a lot of like tasks with children, I think. But with adults, it's the opposite. There are more like functional studies. They like EEG, fMRI studies with stuttering. So they don't, that's why in this figure, for the children, they show like a structural neuroplasticity pattern, but with the adults, they show more of like a functional reorganization pattern, so that they can't compare one-to-one because of these different, focus of
I
studies.
see. I see. Do you know why that is? Like, why can't you study kids
I think
functional?
probably, I mean, if they put a kid in a scanner, they have limited time. They can't do like a lot of like speech tasks, or it's difficult with kids, especially with the like 2 to 4 age 2 to 5.
Mhm.
I can imagine that might be the reason.
Okay. Okay,
Yeah.
thank you. I have a second question as well, if you have,
Yes.
or maybe we have two minutes left. It's going to be quick. So you also mentioned the genetical component, right? And Steph just put a paper, shared a paper in the chat. So in the beginning, you also said that there is like there are different neuroanatomical activations, for example, regarding the putamen, right? Do you know about studies that have looked at not only adults and kids, but just parents and their kids, whether there are like some correlations between, their neuroanatomical abnormal, like functional abnormalities regarding those structures, or not?
Oh, you mean like, is it an hereditary thing?
Exactly, where is basically the root of the
Yeah.
inheriting that, since there is the genetical component. You said that people of like the kids of parents who are stuttering are less likely to recover.
Yeah, they don't
Okay.
mention in the paper, no. Mhm.
Okay.
Yeah.
Okay, thank you. Thanks
Yeah,
for the nice presentation.
thank you. Yeah.
And Chris, final question.
Yeah, thank you for this paper. Is there a possibility that there would be several like sub uh, um, it's like differences, like different things that would arrive to the same symptom of stuttering? Is it possible that we're trying to put everything under the same it is stuttering, but could there be several mechanisms that would lead to the same symptoms? That's what I mean.
Yeah. Yeah.
Because it looks like there is a lot going on, a lot for like
Mhm.
um in children, in adults, between sexes, so
Yeah.
maybe it's not one thing that arrives to stuttering.
Yeah, yeah. No, I agree. I mean, I think that's they point this out in one part of the paper with this, inter and intra individual variability. So stuttering varies so much even within individual. Like they have these episodes, like weeks that they stutter a lot, but other times that they don't stutter. So I don't know, like maybe some stressful event is going in their life, and now when they, it triggers more stuttering, or they don't know like why within individuals stuttering frequency or severity is variable, and also between individuals, like everybody every stutterer has a different background, different stuttering onsets, like different so that's why it's hard to, I think, find just one neural circuit that underlies stuttering, because stuttering types differ a lot, like stuttering instances differ. So I don't know, they yeah that's why I think there is still a lot more to explore in this. So yeah, I don't have a clear answer to this, and neither in the
Maybe it's
paper
also
they
a
present
little bit
one. Yeah,
understudied because
yeah.
it's not like life-threatening.
No, it's not life-threatening, and then people develop some strategies to hide their stuttering, or there are like basic like speech therapies that they can do. So there's just not. And also, I think that fMRI studies of stuttering is so difficult because they have to articulate, like produce speech in the scanner. So that's why, and also with the EEG, like if you also the jaw movements, the articulatory movements also cause like noise artifacts. So imaging of stuttering is also difficult. So that's one reason. So I think, yeah, there's still a lot more to explore in there. So that's why, yeah, they published this paper basically. So yeah.
Thank you, Maggie. I'm actually quite excited about the idea of the mystery papers. I was completely unaware of that concept before.
Yeah, like stimulating interest in one area. There's yeah, I like that too. It's not a review paper, like you don't have to review and everything, and compare and contrast things. This is just like unsolved mysteries point out. It's nice.
So
I like that.
It's gonna keep us busy for a while. Great. Thank you so much for presenting the paper. We will have another Neuroccino next week, and Anna's taking over the hosting. Thanks so much for that. And we should also have a CNS talk next week that Michelle will take over the hosting for. So thank you both for doing that. And with that, I wish you an exciting week in science. Bye.
Bye, guys. Thank you.
Bye bye.